In the middle of the 20th century, humanity looked at the bright cloud tops of Venus and saw a mirror of Earth. The scientific consensus was optimistic. They described a wet, tropical world. Because the clouds were so thick, astronomers assumed the surface was shielded from the sun. They imagined a humid, global swamp that was potentially capable of supporting life. This hallucination was so deeply embedded in the mission planning that the early Soviet probes launched with sensors specifically calibrated to detect water. The reality was a shock. The atmosphere wasn't a shield, it was a lid. It trapped solar heat in a runaway greenhouse feedback loop that pushed surface temperatures to 475 degrees Celsius. The first generation of probes didn't just fail, they were deleted. The atmosphere of Venus didn't treat them like spaceships, it treated them like aluminum cans under a hydraulic press. The telemetry died before they even saw the ground. This total destruction forced a new, darker consensus. The scientists pivoted. They decided that even if a machine could survive the crush, it would be blind. The atmosphere was 90 times denser than Earth's. The models predicted that zero sunlight could penetrate that deep. The surface of Venus wasn't just hot. It was locked in eternal, absolute darkness, but the Soviet engineers were stubborn. They ignored the darkness model. They built Venera 7. They stopped trying to build a spaceship. They effectively built a submarine. They forged a titanium sphere capable of withstanding 180 atmospheres of pressure, double the calculated load. They stripped out the science gear. They removed the windows. They turned the lander into a blind, armored tank designed to do one thing: survive the fall. It launched in August 1970. It hit the atmosphere and fell like a stone. The parachute failed. It slammed into the rocket 17 meters per second. The mission control team marked it as a failure. Another dead robot on a dead world. But then, an astronomer looked closer at the raw radio static. There was a pattern in the noise. The probe had toppled over. It was lying on its side, cooking in the heat, but it was whispering. For 23 minutes, it sent back temperature data. It confirmed the 475-degree nightmare. It proved that a titanium sphere could hold back the ocean of air, but it also proved that the planet was guarding its secrets. We knew the surface was there. We knew it was hot, but we were still blind. The pressure was only the first guardian. The second was the heat. The surface of Venus sits at 475 degrees Celsius. This is not just a weather statistic, it is a weapon. It is hot enough to turn a solid block of lead into a puddle. It melts zinc. It melts tin. If you expose a standard silicon circuit board to this environment, it does not just overheat, it dies instantly. The electrons simply stop listening to instructions. The Soviet engineers realized they were fighting a losing war. You cannot insulate a lander against this kind of energy. Insulation is just a delay tactic. You can wrap the machine in blankets, but the heat is patient. Eventually, it gets inside. You cannot use active cooling. You cannot use fans. You cannot use radiators. A radiator works by dumping heat into cooler air. On Venus, the air outside is a blast furnace. It is hundreds of degrees hotter than the machine itself. So, the design team made a radical decision. They stopped trying to survive indefinitely. They decided to build a machine that was already dead, it just didn't know it yet. They turned the lander into a sacrificial heat sink. Before the probe separated from the mothership, they pumped supercooled fluid through its veins. They dropped the internal temperature of the titanium sphere to -10 degrees Celsius. This gave them a thermal head start. It was a block of ice falling into a volcano. But that wasn't enough. To handle the friction of the descent, they packed the interior of the hull with a strange chemical sludge called lithium nitrate trihydrate. This material melts at exactly 30 degrees Celsius. The engineers were exploiting physics. When a solid turns into a liquid, it absorbs a massive amount of energy without getting hotter. As the Venusian heat hammered against the armor, it didn't cook the computer. It spent its fury melting the sludge. This phase change trick bought the robot roughly 1 hour of life. 60 minutes. That was the timeline. After that, the coolant boils, the electronics fry, and the mission ends. They had 1 hour to capture the visual history of a lost world, but they couldn't use a camera. A standard television tube from the 1970s was a fragile glass vacuum. Under 90 atmospheres of pressure, a glass lens would shatter instantly. If the window cracked, the sphere would implode, so they didn't use a lens. They built a telephotometer. It was a mechanical eye. It lived safely inside the cooled titanium shell, peering out through a tiny, bulletproof quartz porthole. Inside, a small mirror ticked back and forth, reading the world one single pixel at a time. It measured the brightness of a dot, then moved to the next dot. It didn't stream video, it trickled math. The probe sent a stream of numbers back to Earth, where supercomputers stitched them together into a mosaic, line by agonizing line. It was slow. If the probe melted before the scan finished, the image would just cut off. They were trading speed for armor. In October 1975, Venera 9 survived the fall. The scientists were terrified of the dark. They assumed the clouds were so thick that the surface would be pitch black, locked in an eternal night. They bolted massive halogen floodlights to the hull, preparing to light up the gloom. They were wrong. When the lens cap popped off, the sensors were flooded with light. The floodlights were useless. The world was bright. The ambient light was comparable to a cloudy afternoon in Moscow. The atmosphere scattered the sunlight, creating a soft, shadowless glow. The image that slowly built on the screens and mission control destroyed the geology models. The scientists expected a desert. They expected sand dunes worn smooth by eons of erosion. The atmosphere is dense, so they assumed the wind would act like sandpaper. Venera 9 showed the opposite. The ground was a field of razor-sharp angular rocks. The edges were jagged. This meant the surface was geologically young. It meant the wind was dead. The air was so calm that the rocks had sat there for millions of years without losing their edge. The horizon was clear. There was no dust. There was no fog, just endless, sharp rock. But we were still colorblind. We were seeing hell in black and white. It wasn't until 1982, with Venera 13, that we finally saw the true complexion of the planet. The probe scanned the world through red, green, and blue filters. When the data was recombined, the result was suffocating. Everything was orange. The sky was orange, the rocks were orange, the horizon was orange. This wasn't a glitch, it was atmospheric physics. The air is so thick, it acts as a spectral prison. It absorbs every wavelength of blue and green light before it hits the ground. The lander carried a color calibration chart with a strip of white paint. In the photo, the white paint is orange, the blue paint is black. If you stood on the surface of Venus, your eyes would fail you. You would see the universe in sepia tone. Venera 13 also had ears. It carried a microphone designed to listen to a dead world. It recorded the first sounds ever captured on another planet. It heard the wind. The telemetry said the breeze was only moving at half a meter per second. On Earth, that's nothing, but on Venus, the air is 60 times denser than ours. A gentle breeze hits with the force of a rushing river. The microphone picked up a low, constant aerodynamic drone. Then, the probe fired a pneumatic drill to taste the rock. The microphone captured the violent explosion of the pyrotechnic charge and the grinding scream of the drill bit biting into basalt. The dense air carried the sound perfectly. It wasn't just hot, it was loud. Then came Venera 14, and with it, the most expensive slapstick routine in the history of spaceflight. The lander landed in a smooth, cracked plane. Its mission was to test the physical density of the ground. It had a spring-loaded arm meant to swing out and hammer the soil. By measuring how far the arm penetrated, they could tell if the ground was soft dust or solid rock. The sequence was automated. Step 1. Fire the pyrotechnic charges to pop the camera lens caps. Step 2. Swing the hammer. The lens cap fired. It popped off perfectly. But it didn't roll away. It landed exactly, precisely, on the spot where the arm was programmed to strike. The arm swung down. It smashed into the titanium cap. The telemetry beamed back to Earth reported that the surface of Venus was incredibly hard and metallic. It showed zero compressibility. The data was technically accurate. The probe wasn't measuring the planet. It was measuring our own trash. The camera scanned the scene and sent back a photo of the arm pressing firmly on the discarded cap. The actual alien soil lay just centimeters away, untouched. We had flown millions of kilometers. We had survived the crush. We had survived the fire, only to be defeated by a lens cap. The mission didn't end on Venus. It ended in a dusty archive. For 30 years, the magnetic tapes holding the raw data sat on shelves, slowly degrading. The images the world saw in the 1970s and 80s were grainy, analog reconstructions. They were ghosts of the real signal. The scientific consensus solidified into dogma. Venus is dead. Venus is sterile. The pressure is too high. The chemistry is impossible. But in 2012, a Russian scientist named Leonid Kaysan-Fomality broke the dogma. He wasn't a fringe theorist. He was one of the original architects of the Soviet space program. he didn't look at the photos. He went back to the raw telemetry. He realized that the camera wasn't taking snapshots. It was scanning. By aligning the scans over time, he created a movie, and in that movie, he saw something moving. He called it the Scorpion. In the first scan, the soil is empty. 7 minutes later, a structure appears. It is 15 centimeters long. It has a body and a curved tail. In the next scan, it is gone. Keinfeld argued that it emerged from the dirt, hesitated, and then crawled away. He claimed we had found life based on exotic chemistry. The scientific community rejected him immediately. NASA and Russian experts looked at the same data and saw something much more mechanical and perhaps much more terrifying. They argued the Scorpion wasn't a creature. It was a piece of the lander itself. The probe was wrapped in layers of insulation and plastic. As the internal temperature climbed toward critical failure, the machine began to shed its skin. The materials melted, peeled, and snapped off. The movement wasn't biological. It was the result of the lander disintegrating under the thermal stress. But this explanation reveals a different kind of horror. The footage doesn't show a static, dead painting. It shows a violent interaction. The lander was groaning. It was warping. It was being digested by the environment. The impossible shapes were the dying convulsions of the machine itself, captured in slow motion. That was the last time we looked. The camera on Venera 14 was the final eye humanity opened on the surface of Venus. That was 1982. Since then, we have sent nuclear-powered rovers to Mars that stream high-definition video every single day. We have flown past Pluto. We have mapped the entire solar system. Yet for the planet closest to Earth, our visual memory is frozen in the Cold War. We rely on data collected by a titanium sphere that melted 40 years ago. We assume we know what is down there. We assume it is just rocks and acid. But until a new lander survives the descent, those yellow, grainy panoramas remain our only true view of hell. Subscribe to follow the unfolding story.